everyone, this is Erica, and I'm going to be doing chapter 659, number 59 for physics C. So the problem reads, the expression force equals ARV plus BR squared V squared gives the magnitude of the resistive force in newtons exerted on a sphere of radius r in meters by a stream of air moving at speed v in meters per second, where A and B are constants with appropriate SI units. So A equals 3.10 times 10 to the negative fourth, and B equals 0.870. And we know that problem A uses the drop radii 10 micrometers, B uses 100 micrometers, and C equals 100 millimeters. So for A and C, the question reads that we can ignore one of the two contributions to air resistance because one of them is larger than the other, and that makes the other one non-existent basically. Alright, so let's get started on the problem. Alright, so this is Physics C, chapter 659. So I already drew the little droplet from earlier. So this is our water droplet, and as it falls down the sky, it's holding its weight, right? And then this is the air resistance that's pushing up against it. So we are given in the problem that force equals ARV plus BR squared V squared, which also, since force equals mass times acceleration, is mass times acceleration. So in the first part of the question, part A, we want to know how much speed there is going to be, right? Depending on the different weights. So part A has the weight radius. The radius of the little water droplet is going to be 10 micrometers. All right. So we know that we have to find mass in order to plug it in, right? We don't know the mass of the droplet. So what we're going to do is, from chemistry and from other things, we know that mass equals pressure times velocity. No, volume, excuse me, sorry. From the formula that we know, P equals M over V, right? So we're just going to substitute that back in. So we know that the density of water equals 1,000 kilograms per meter cubed. And we know the volume of a sphere is 4/3 pi r cubed, correct? All right, so now we're just going to plug those numbers in. So 1,000 times the volume, which is going to be 4/3 pi, and radius is 10 micrometers, which means if you convert it into meters, it's going to be 1 times 10 to the negative fifth meters, and then cubed, right? That's our mass formula. So now we're going to take that. I'm going to leave this undone because it's just a lot easier. Or you know what? Let's go ahead and plug that in. I'm going to see 1,000 times 4/3 times pi times 10 to the negative fifth equals, which is around 4.11 times 10 to the negative 11th, or that's what it should be. I don't know what happened here. Anyway, we're going to ignore that part before we use the calculator. It's going to be 4.11 times 10 to the negative 11th. That is mass times acceleration, which in our case is gravity. All right. And then, so we're going to plug in the values for A and for B that the textbook gave us, which is going to be 3.10 times 10 to the negative fourth times r times velocity plus 0.870 times r squared velocity squared. So now we're going to plug in R from before, the 10 micrometers, in meters. Keep in mind it has to be in meters. And we're going to get 4.11 times 10 to the negative 11th equals 3.10 times 10 to the negative 9th V plus 0.870 times 10 to the negative 10th velocity squared. So we know from early in the problem that the problem said that we can ignore one of the lesser contributing ones, which means that this one is going to be lesser than this one. Think about it. Times 10 to the negative 10th is significantly smaller than times 10 to the negative 9th. So we're going to cross that out, and just use basic algebra to solve for V. If you plug that into your calculator, V is going to be 0.0132 meters per second. And this is our part A. That's going to be the speed of the water droplet falling if the radius of the water droplet is 10 micrometers. All right, so problem 2. Problem B. Problem B is basically the same setup as part A. So instead of 10 micrometers, it is going to be 100 micrometers. Yay! All right, so like the same time, like the one previous, we're going to do mass equals density times volume, and we're going to get mass equals 4.11 times 10 to the negative 4th. And then, so, in other words, 4.11 times 10 to the negative 4th equals 3.10 times 10 to the negative 4th RV plus 0.870 R squared V squared, which, if you plug in this 100 micrometers instead of 10 micrometers, we are going to get 4.11 times 10 to the negative 4th equals 3.10 times 10 to the negative 8th V plus 0.870 times 10 to the negative 10th V squared. Now, using the quadratic formula, we know that V equals negative B plus or minus B squared minus 4AC over 2A. Now, we're going to use this as C. This is negative C, right? Because if you put it on the other side equation, you guys get that. Sorry, I wasn't including this in the video, was I? All right, so basically we solved it all the way here, and then we're going to use the quadratic formula to solve for V. So this is going to be negative C if you put it on the other side. And this is going to be our B, and this is going to be our A term. Right, so velocity equals 1.03 meters per second. And ta-da, you're done with C. The reason why we didn't cancel one of the values of V is because for them, they're basically about the same. Times 10 to the negative 8th and times 10 to the negative 10th. You can't really cancel it because it's going to be significant to times 10 to the negative 4th. Anywho, part C, we're almost done. So this time we're going to assume that V is greater than 1. And we also know that our radius is going to be 1 millimeter. So if we plug it in from the equations above, we're going to know that M equals density times volume, which is going to be about 4.11 times 10 to the negative 5th. And then we're going to plug it into the above equation. So 4.11 times 10 to the negative 5th equals 3.10 times 10 to the negative 7th V plus 0.870 times 10 to the negative 6th V squared. What I did here is this is actually a RV, so it's the constant times radius times velocity, which is right here, right? And same here. This one is going to be BR squared V squared. The reason why is I just wanted to save time. Continuing. So now we're going to cross this one out because this times 10 to the negative 7 is significantly smaller than times 10 to the negative 6, and it doesn't really have any factor in our play here, and that's what the question said in its original wording. All right, so now we're going to solve for V squared, right? We're going to solve for V. So 4.11 times 10 to the negative 5th equals 0.870 times 10 to the negative 6 V squared. V equals 6.87 meters per second if you plug it into the calculator using basic algebra. Ta-da! Here is our score. Here's our answers. You guys did it. All right, just one thing I wanted to make sure you guys understand is that terminal velocity, the acceleration, it no longer accelerates faster because the force that the air resistance gives us is the same as the force of gravity, or slightly the same or slightly slower. Same thing. The reason why it would accelerate at the very beginning when you first drop like a water droplet or a ball or something is because the amount of the gravitational force is larger than the resistive force. All right, I hope you guys have a good day and good luck with physics homework and physics shenanigans. Adios.